today we're going to review some of the logarithm stuff that you have learned in years past, how to solve logarithmic equations, that sort of thing. We will not be getting into the derivatives and integrals of logarithms until next section. So we're going to do a crash course in logarithms the next couple of days. So today, Gene Napier invented logarithms. Don't forget in class tomorrow to ask me, how did people calculate logarithms before there was calculators, or how did they calculate trig values of angles that aren't on our unit circle, that sort of thing. I have an interesting item I can show you. So, some rules from pre-calc. I'll kind of underline them as you go. There's not a ton to write. If f of x equals a to the x, then log base a of x equals y. Those are inverses. And it's actually, I think that's backwards. Yeah, log base a of y equals x. It might be correct on your sheet. A log or an ln is an exponent. And then there are a couple rules that you could memorize here. One of them being that log base a of a to the x is equal to x. And that's true for all x from negative infinity to infinity. And also a to the log base a of x equals x. It's almost as if your base and your log's base are the same. They kind of cancel out. Rule number 4, we can separate logarithms. So if it's multiplication, multiplication, they can be separated by addition. If it's division, it can be subtracted to separate. And a log base a, when there's a power in our logarithm, that can be moved out front, just like we have here, r log base a of x. None of these rules are new. Look over them a little closer if you need to, but it always review from previous years. So, if a is greater than 1, then the limit of log base a of x equals infinity, and the limit, as we approach infinity, of log base a of x equals infinity. Apparently that's there twice. And as we approach 0 from the positive side, it's negative infinity, because all logarithmic functions look roughly like this. There are some changes depending on what is plugged in, or if it's stretched or compressed or split, but that's the general approach. The limit as x approaches infinity of ln of x is infinity, and as x approaches 0 from the positive side, it's negative infinity. So natural logs look very similar to logarithms as well. What point do you think all of them go through? Think back to our exponentials. They all go through 1, 0, unless they've been moved up or down some, or left or right. So, 8, if your base is e, we don't write log base e. You can, you won't look very smart, you probably won't get all the points. You won't get all the points from me. But, log base e of x is the same as ln of x. And if you have a natural log of x equal to y, you can change the form from logarithmic to exponential. And you can change it the other direction. The catch being is exponential has to be in exponential, meaning there's nothing multiplied out front. You got to move everything except the base and the exponent to one side and leave the base and the exponent on the other, then you can change the form. Similar rule to what we saw earlier, because this base is the same as the base in our logarithm. That's a rule you should memorize. Same thing here. Similar rule to the log, to the 2 I highlighted a couple pages back. And the same as these here on the 3. Just with a log instead of a natural log, although they're the same with different bases. And ln of e is 1, which makes sense because ln of e, our base is an e, equals 1. E to what power equals 1? Or, sorry, e to what power equals e? Well, it's 1. And we have a change of base formula, and it says that we can do log of a of x can either be log of x over log of a. Notice x is what was in our logarithm, and a was our base. Or you can do it with natural logs also. Natural log of x over natural log of a. You're probably going to see the second one, or use the second one a little more, because it's not a natural thing to use natural logs when you've used other logarithms. So you just get them out using extra log. So, let's solve them. Says, find the value of log base 3 of 81 equals 4. Well, think of this as we're trying to figure out what it equals. If I change the form, 3 to what power equals 81? Well, that power has to be 4, so that equals 4. This next one, think of this as equaling x, and our base is an e, so when we change to exponential form, e to the x equals e to the negative 100, that means that our x is negative 100. So we have those two answers on number 1. 2 says find the exact value. Well, if you notice, this is subtraction, which means we can combine these. Remember, when we combine them, there's only one log out front. We can combine them by division. Log base a of 320 over 5 becomes log base 8 of 64. If you think about this equaling x, 8 to what power equals 64? That means our answer is 2. Similar idea over here. We have addition going on, so we can write this as 2 to the log base 2 of 15. Addition can be combined as multiplication, and 3 times 5 is 15. So, now, you remember our rule, you will know that this is equal to 15, and that is referring back to rule number the add-on, rule number 3. So, if you have questions on those, watch it again, come talk to me tomorrow. Expand. This, we're going to spread it out as much as we can. First thing I'm going to do is rewrite it. This is actually the ln of a times b squared plus c squared to the 1/2. I'm going to start by moving my 1/2 power out front. Then if you notice, I have multiplication going on here. So I can make this 1/2 and separate into the natural log of a plus the natural log of b squared plus c squared. But I have to distribute my 1/2, so 1/2 ln of a plus 1/2 ln of b squared plus c squared. And that's all the farther we can go because we do not have any rules that allow us to separate addition in a logarithm. We can spread out multiplication, we can spread out division, but nothing else. This next one, we're going to put it all together. You notice we have some addition and we have some subtraction. I'm going to start with the addition. But this is going to be ln of x plus y times x minus y, because addition can be combined by multiplication, minus, and I'm also going to move up my power. So this becomes ln of x squared. So this is ln of x squared minus y squared minus ln of x squared. Now, the subtraction can be combined by division, so this becomes ln. If it's going to become division, we have the x squared minus y squared in our numerator, and an x squared in the denominator. And that's all the farther we can combine it. And on your paper, there's a small chance that these might be these. Sorry about that. Whichever they are, it doesn't simplify more, so it works out. Number 5 says, use formula 7 to evaluate the answer to 6 decimal places. Some of your calculators will allow you to put in log base 2 of 7. I believe 84s will do that. Possibly Inspires. The 83s will not. Which means we need to know what log base 2 of 7 means. Well, according to our change of base formula, log of 7 over log of 2. If you've got questions on that, glance back to formula 7. Actually, the base change rule, we've numbered it number 13. The book refers to it as formula 7. I'm not sure why, but rule 13, you can type that in your calculator. and you find out that it equals 2.807355. Now we're going to solve for x. As I look at this first one, letter A, I notice that my x is in an exponent. To solve for an x, I have to get it out of there. But before I can get it out of there, it has to be in exponential form. And it is not in exponential form as long as this minus 7 is here. So I'm going to add the 7 to the other side. I've got e to the 2x plus 3 equals 7. Now, I can change the form to natural log, because we have an e, of 7 equals 2x plus 3. And to solve this for x, ln of 7 minus 3 equals 2x, which means that x equals ln of 7 minus 3 all over 2. And do not put parentheses around that 7 minus 3. Only the 7 is in the natural log. So ln of 7 minus 3 over 2, and if you needed a decimal, you could put that in your calculator. Part B, also similar. I have an x that's in a logarithm that I'm trying to solve for. To get it out of the logarithm, I have to change forms. So e to the negative third equals 5 minus 2x, which means e to the negative third minus 5 equals negative 2x, and x is e to the negative third minus 5 all over negative 2. And you could get a decimal for that if you needed to. As you work on these problems, other things are going to pop up that hopefully you will remember from pre-calc and algebra 2. Some rules about logarithms. I've covered most of them, but we didn't do examples of all the rules, so refer to those rules a lot. Do your best in class tomorrow. Make sure you